Solving rational equations. Of course. This is what we learn all these techniques for, so we can actually solve equations. We're going to practice first using synthetic division. We'll take this one, which we remember that the divisor has to be organized like this, and then we take the A and we place it right here. In this case, what is the A? Well, it's got to be A minus, obviously it's a plus 3. So we're going to have a 3 here, and then we take the coefficients of each of the powers, and we have to represent every power here, and you'll notice one of them is missing. We've got 4, 3, 2, and 0. So we're going to leave a place for 4, 3, 2, 1, and 0. The coefficient of the fourth power is 3, positive 3. The coefficient of the third power is a negative 7. Coefficient of the second power is a negative 5. The coefficient of the first power is 0. The coefficient of the 0 power is negative 3. Now you remember we sort of prime the pump here, get things started, by bringing down that first leading coefficient. Now we're ready to actually start our calculations. We always start by multiplying the divisor times the leading coefficient. It gives us a product which we place here, 9. Now we add, so we have a plus 2, positive 2. We multiply these, 6. We add, plus 1. We multiply, a positive 3. We add. We multiply. We add. Now we actually were dividing by x minus 3 when we went through this synthetic division. So what used to be x to the fourth power is now x to the third power. It has been reduced by 1 power. And this right here, this is our remainder. It didn't go in evenly, so this tells me that x minus 3 is not a factor of this polynomial. Let's also, to get ourselves ready for today's lesson, work on solving this. I know that if I want to solve for x, I have to get x all to one side. So I guess it might make sense for me to add x to both sides, leaving just a 1/2 on this side. Now you know from your experience with me that I'm not that crazy about dealing with fractions. So what could we multiply every term by to get rid of both of the fractions? 6. If I multiply this all by 6, I get 6x over 3 plus 6x over 1, but I won't bother writing that, plus 6 over 2. And this will simplify to 2x plus 6x equals 3. It's getting easier, isn't it? Now I'm just going to combine these two because these are like terms. They both have x to the first power. 8x equals 3. X is equal to 3/8. All right, that's our little warm-up. Now let's get down to business here. Solving rational equations. What values of x can be used in this expression? Well, I'd say almost every value of x, except for any value that would cause my denominator to equal 0. X minus 2. If that were to equal 0, I'd be violating a very important rule, wouldn't I? You may not let a denominator go to 0. What value of x would cause this denominator to go to 0? That's right. So what I can say about this is we can use all real numbers. This is a symbol for all real numbers, except x equal to 2. That one we may not use. So we can refer to this as a domain. What can you put in? Anything except 2. Another way we could write this is, all right, I don't know how this thing works sometimes. Crazy things it does. So my domain is all real numbers except that x cannot equal 2. That is the one exception. What least common denominator would clear this equation of fractions? This gets a little more complicated than the one we just did. It's got to have all of these factors. It's got to have 5. It's got to have 4. And there's nothing common between these. And it's got to have x. So I'm afraid, I'm sorry to say it, the best we can do is 20x. Sometimes we would find we had a common factor here and we wouldn't have to just multiply them all together. Is 0 a possible solution for this equation? Think about it. If we let x equal 0, what would we be doing? Again, we would be allowing the denominator to go to 0. We may not let a denominator go to 0. This is a very important thing for us to keep in mind as we work with rational equations. Okay. If I go to rationalize this, my least common denominator is 3x, so I could multiply everything through by 3x. I would have 6x over 3 on my left-hand side, and 3x over x on my right-hand side. Now, one of the things I should have noticed right off, it is important to note it right off, is that x may not equal 0. Let's note that and keep it in mind. Because what if we find out that the solution that we get is 0? Then we have to say there is no solution. Okay, this will simplify to 2x. This will simplify to 3. And we find out that x is equal to 3/2, which is perfectly acceptable. As long as it's not x equals 0, we are in business. Good answer right there. How about this one? I could clear this one with x and x minus 4. I could do that, couldn't I? And then simplify it and solve it. However, I want to take you back to something you learned a while ago. Remember back in an earlier algebra class, you learned about proportions. If you have one fraction, and this is one fraction on this side, equal to another fraction, you can cross multiply. I could have done it up here, and I certainly could do it here. I think it would be easier. Cross multiplying would give me 3x equals 2 times x minus 4. Now I'm going to distribute this. I'll have 3x equals 2x minus 8. I'll subtract 2x from both sides. I'll have x equals minus 8. Oh, and I did it again. Back here, shouldn't I have considered limitations on the domain here? Values which I cannot allow x to take. X certainly cannot equal 0. Is there anything else that we can't allow x to equal? That's right, we can't allow it to be 4. But in this case, that was not the solution. The solution was negative 8, and that's perfectly acceptable. This time I have it fresh on my mind, and I'm thinking the domain of this has to be something other than 3. All right, so let's try our cross multiplication. We'll have x times x minus 3 equals 5 times x minus 3, which will give us x squared minus 3x. What is that you're saying to me? Oh, no, we cannot just eliminate this x minus 3 because it has a variable in it. It might have part of our solution. So, no, we're not going to cancel that out. Then we get 5x. Thank you for mentioning that. Now, anytime you see a quadratic second power, I want you to think of the zero product property. I love this thing, you know I do, because its name says it all. You look for the zero, then you look for the product. It really tells you what to do. So we need to get a 0. To get a 0, we're going to subtract 5x and add 15 to both sides. That'll give us a negative 8x and a plus 15. And we have now our 0. So we've got the 0, but we don't have the product. This is where all that work we did with factoring comes in, because we can rewrite this as a product, 2 factors. And what will it be? Well, we know it's got to be x and x because it equals x squared, and we also know that we've got to have 2 factors of 15 that when we add them together will give us a negative 8. That would have to be a negative and a negative, a 3 and a 5. So what do we get for answers? X minus 3 equals 0. That's one of the many equations. And x minus 5 equals 0. So x is equal to 3, or x is equal to 5. Well, We do have a problem, don't we? Well, here it is. We said that we can't let x equal 3. So clearly, this one is disallowed. The answer, even though in our solution process, which was entirely correct, we got 2 answers, this one is disallowed. So we only have one legitimate answer, and that is 5. Now we're going to do a few more difficult problems. I have students who ask me, please, Mrs. Turner, will you do some of the more difficult ones? Let's see, what would we do with this one? Well, first of all, we don't have a proportion, so I cannot simply cross multiply. A proportion has only one fraction or one term on each side. Let's go back. In all of these, I had only one term on each side. So I could cross multiply all of those. But now we're getting into more difficult ones where I cannot do that. However, I can clear the fraction, can't I? By multiplying everything by an x. Then I would have x squared plus 3x over x, but I'm just going to write 3, okay? I'm going to say, okay, I've got x over x, that's the same as 1, equals 4x. Again, we've got the second power. You think 0, product property. We need the 0. So we subtract 4x. X squared minus 4x plus 3 equals 0. Oh, I did it again. How could I do this? I should always start out by saying, are there any values of x which are disallowed? Well, yes, there certainly is. We cannot let x equal 0. Let's make a note of that. I'm so sorry. I should do that right off. All right, I've got the 0. I need the product. Product we achieve by factoring, something multiplied by something else. That's what a product is. And this is again going to be x and x. Two products of a positive 3 that when we add them, two factors of a positive 3 that when we add them together give us a negative 4. So they're both going to be negative. And there's actually only one possibility here, 3 and 1. So we're going to have x minus 3 equals 0, and x minus 1, it's a minus, equals 0. Those are our many equations. Remember that the 0 product property tells us that if you're multiplying two things together and they equal 0, then one or both of these must also equal 0. So that's why we set up these many equations. X can be 3, or x may be 1. Okay, so our answer, x can be either 3 or 1. How about this one? Woo! I am going to remember to first consider what x cannot be, just in case it turns out to be one of our answers. We cannot let x be 1. We cannot let it be 2. Because if it were, this would, if it were 1, this would be 0. If it were 2, this would be 0. And we see the same thing again over here. Wonder what would be the best way to handle this. I don't think I want to clear the fraction because it's going to make a terrible mess. I think it would be advisable here if we went for the least common denominator. Now my choices are based upon which is going to be the least work. In this one, I think if we go for the least common denominator, that will be the least work. Which means that this term needs to be multiplied by a fancy one in the form of x minus 2, because it's missing x minus 2 in its denominator. And this one is missing x minus 1 in its denominator, so we're going to multiply this one by another fancy one, but this one composed of x minus 1 over x minus 1. All right, let's work these out. I'll have x minus 2 plus x minus 1 all over x minus 1 times x minus 2, because we have a common denominator. Now, the equals, which I've nearly obliterated here, I'm not doing anything to this side of the equation yet. What's going to happen here? I'm going to get, let's clear these, let's see if I can do it fine enough. I'm going to clear these parentheses because I actually don't have to distribute anything. Oh, I'm making a mess of it. All right, I'll rewrite it. But I just cleared the parentheses. That was just a plus, and this was a 1. So I've got some like terms here. It ends up being 2x, right? Minus 3 over x minus 1, x minus 2. And on this side, nothing has changed. Let me point out to you now that I do have a proportion at this point. I have a single term on this side, complicated looking, but still a single term. So now I could cross multiply, and that's exactly what I'm going to do. I'm going to say 2x minus 3 times, well, what would this be if I multiplied it out? Let's do that. X squared, and then I'll have outside minus 2x, inside minus 1x, so minus 3x plus 2. So that was cross multiplying here and here, and that's all going to be equal to x squared minus 3x plus 2. So I'll have 2x cubed. What I'm doing is first I'm going to distribute this. Minus 6x squared plus 4x. Did I get that correctly? 2x cubed minus 6x squared minus 4 plus 4x. Now I'm going to do the rest of it with the negative 3. So I multiply everything in that trinomial by negative 3, and I get a negative 3x squared, a positive 9x, and a negative 6, all equal to x squared minus 3x plus 2. Let's see if we can move this down a little bit. Maybe extend the page. get this out of our way. I'm going to add like terms. I've got a polynomial, clearly, and let's get all of this over on one side so we can have perhaps the use of the zero product property. I'm going to subtract x squared from both sides. I don't have to worry about this term. It's not going to change. And when I subtract x squared from both sides, I get a minus 10x squared. And then I'm going to add 3x to both sides. So I'm going to get a plus 16x. And I'm going to subtract 2 minus 8 equals 0. Now one of the things that hits me, and you should always look for it, I have all even numbers. So clearly I could divide this whole thing, including the 0, by 2. When I divide 0 by 2, I still have 0. But everything else is going to change. Now when you have something like this with 4 terms in a polynomial, you've learned a technique for this, factoring by grouping, where you try pulling out, let's see if that would work, pulling out a common monomial from the first 2 and a common monomial from the second 2. In this case, I've got x squared is common to both the first and the second. And that would leave me with x minus 5. Oh, this doesn't look like it's going to work for me. And out of here I could pull a 4. And we'll have x minus 1. Well, that didn't do it. That clearly didn't do it. I needed to have these match up, so I can't do it by factoring by grouping. I'm going to move ahead on this lesson and we'll come back to this one because I have a suspicion now, and you're probably very aware of it. Did I make some foolish math error along the way? We'll find out. Oh, done? Well, then I have time. I have time to work on it. All right. After all, we're only at 28 minutes. You guys wanted some difficult ones, right? Okay, let's see. What did I do wrong? Did I do anything wrong? That's a fancy one. Fancy one in order to get a common denominator. And this was being added, so I could just say x minus 2 plus x minus 1, which became 2x minus 3. Nothing wrong with that so far. And when I multiplied this out, did I do it correctly? X squared minus 3x plus 2. I did that correctly. And then I had cross multiplied. And that, when I wanted to make this into a polynomial, did I do it correctly? Let's see. That would be, I'm going to mark these as I check them. 2x cubed, that looks okay. And a minus 6x squared, that looks correct. And then a positive 4x. Then I'll have negative 3x squared, a positive 9x, and a negative 6. I don't see an error yet. We add these together. You know, I guess maybe it's hard to see your own error. I subtract x squared, and it does turn out to be this. I add 3x, and it becomes this, and I subtract, so, and then I divided everything by 2, so this became a 1, minus 5, plus, I don't see an error, and I thought that I would be able to do factoring by grouping. We're going to have to do this one back in class. I could try dividing by, I'm going to try this. I'm going to try dividing, but for those of you who don't want to stick with me, you can hang it up. But for those of you who do, let's try, I'm just going to fool around with some factors. I'm going to see, could I use a, I'm thinking I might be able to factor this with x minus 2. So I'm going to try synthetic division, and that would be a 1, a negative 5, a positive 8, and a negative 4. We'll just see if we can get something even coming out of this. Okay, so 2, a negative 3, a negative 6, a 2, a positive 4. Oh my goodness! Oh my goodness, it worked! Now you're going to think that I had this all planned out. I didn't. So now I know that this is a factor because I got a remainder of 0. And what's the rest of it? It's x squared minus 3x plus 2, which can be factored further, can't it? X minus 2, x minus 2, and x plus, minus. Okay, x minus 2 and x minus 1. Wow. So I could factor, but I couldn't do factoring by grouping. All right, so my many equations tell me I can say x minus 2 equals 0. And of course, that's a redundant solution. Notice how we've got it twice. And then I've got x minus 1 equals 0. So my answer is x equals either 1 or 2. Now let's just check. I can't allow those solutions. So after all that work, I have to say, no, those are not permissible, because if I use them, the denominator would go to 0. My answer here, after working all this time, no solution.